let's take a look at finding inverses algebraically. So we're going to solve functions inverse, right, using 4 steps. Right. The first thing you do is you change this f of x to y. We're very familiar with this already. F of x to y. Then we're going to swap x and y. So this is a little bit different. What we're doing is we're finding the inverse function. So we're going to swap x and y. We're then going to solve for y, and then we're going to replace y with this notation f inverse of x. All right, so this f with a power of -1, I suppose, is f inverse. So it's the inverse function of x. Right. Let's take a look first of all at a linear example, and then we'll take a look at a radical example. So the first thing here, the linear example, right? Once again, what we're going to do, I'm going to leave that up there so that we can see the steps step by step. We're going to change our f of x to y. So this is this change here to y, right? And we're going to get y equals 2x minus 9. Right? No change here, just the f of x, we changed it to y. Now things start to get interesting. All right, so we're going to swap x and y. So we're going to say, okay, x equals 2y minus 9. And this might look unusual to you, right? Because obviously we just changed the two variables. Surely this is not true. Well, what we're trying to do is we're trying to find the inverse. So we're going to end up back with y equals, and then we actually have the inverse function of what we're looking for. So let's do this. Solve for y. So we're very familiar already with solving for a variable. We're going to add 9 to both sides, right, to get rid of this 9. And so we have x plus 9 equals 2y. And then we're going to divide both sides by 2. And that's going to give us y equals this whole mess here, x plus 9 over 2. Right? So now what we're going to do is we're going to replace this y once again with what we started with. So this y here, we're going to replace it with, in this case, f inverse of x equals equals x plus 9 over 2. So this here is the inverse function, right? This here is the inverse function of our original function right there. Okay. Okay. Let's look at a radical example. We just worked with radical example solving radicals. It's no different. We just use the same kind of idea as we did before, except we may have some extraneous solutions, right? So step 1. Okay, we're going to write this as y equals, in this case it's the 8th root of 2x minus 9. Okay. So we're going to swap x and y. So we're still going to have the 8th root of 2, and that's going to be y minus 9. So we're going to swap x and y. So now we have x equals, and this is y, and we're going to solve for y. So go back to your solving radicals to solve for y. Okay, and we get ourselves, well, it's no different really, except that we have a radical to work with. So we have x plus 9 equals the 8th root of 2y. And so by taking the 8th power on both sides, right, that's going to get rid of that, and we plug in. So now we have x Now we have x plus 9 to the 8th power equals 2y. And so we divide both sides by 2 is going to get us y equals. So in this case now, we actually have f inverse of x, that's replacing the y here that we canceled out, right? Replacing the y here equals x plus 9 to the power of 8 over 2. Okay? So that's those two solved for us. Okay, I'm going to pause there for just a second. Let that sink in. All right, so the 4 steps: change f of x to y, swap x and y, solve for y, and then replace with f inverse. All right, let's see it with a few more examples. Okay, here's the key thing here, that it is very important to pay attention to what's outside and what's inside the radical, right? Just watch out here that what's outside the radical must be done before, it must be undone really, before using the parentheses and raising to the power. What's inside will be done after. So we're still going to follow the same steps. Just be really careful. You can't, you got to do things step by step, kind of like PEMDAS when you were working with PEMDAS back in the day, right? So let's look at a few examples. Again, our 4 steps. The first step here is we are going to change this f of x to y. So we have y equals, in this case, the root of x over 3 plus 11, right? Now we're going to change our 2 variables, right? So our 2 variables, now we get x equals the square root of y over 3 plus 11, right? So make sure that you're getting rid of, that you're undoing everything or using the inverse operations of everything else before you deal with this radical. So once again, we're going to subtract 11 from both sides, right? This is already, I hope, familiar to us, right? X minus 11 equals the square root of y over 3. This is multiplying both sides. We need to multiply both sides times 3. So multiply times 3, we get, well, we can multiply out 3x minus 33, if you will, equals the root of 3, the square root of y. And then what we're going to do finally is we're going to square both sides, right? So we're going to square both sides. And that's going to give us, well, I'm going to keep this as 3x minus 33 all squared, though you could actually try and work that out if you like, equals y, right? There's no need to, there's no real need to, so long as you've got the inverse that you're looking for. So we're looking for here the f inverse of x. We're going to replace back in x, f inverse of x for y is equal to 3x minus 33 all squared. Okay, and of course if you wanted to put that as 3 times x minus 11 and then have the whole thing all squared, but just make sure you got your parentheses all in the right places. That's kind of why I distributed this in, just to keep it simple. But you could also in this case have, just so that you see both examples of it, right? This would be a 3 times x minus 11, so you see those nested parentheses, and there's your square right there. So, because obviously the square has to go into the 3, and it's got to go into what we've got going here. So that's a little bit extra. So either one of these would work absolutely fine. They would work no problem. Okay, let's do this again. Let's once again, we're going to replace here. Replace. We've got 3 times, and this is now the 4th root of x plus 11. Right? So the 4th root of x plus 11. So we're now going to switch x and y. So we get x equals 3 times the 4th root of x plus 11. Oh, that's going to be a y plus 11. Now we switch the x and y plus 11. And we solve for y. So divide both sides by 3. We get 3x equals the 4th root of y plus 11. And now we're going to we're going to not square both sides, we're going to raise both sides to that index of 4. And so now we have, now we've got 3x to the 4th power equals y plus 11. And we're going to subtract 11 from both sides. And that's going to give us 3x to the 4th power minus 11 equals y. And so, based on that, replace it back in with an f inverse of x equals 3x to the 4th power minus 11.